Hello, good morning. Welcome back to Tole Math. Today we are going to continue with our set class, and we are looking at multiplication of sets and then rationalization. Alright, we said sets are irrational numbers that are expressed in a square root form. Alright, that cannot be further be simplified, and we've done this once in our previous class. And today we are looking at how to multiply sets. Alright. Now, if you are given two sets, say I'm giving root A times root B. Now, because this is multiplication, we can easily write this as root AB. It's just like having x times y, which is written as xy. Alright. Now, if I'm giving 2 root 3 times 4 root 2. Now, if you look at this, we have coefficients. So all you have to do is to multiply the coefficient first, which is 2 times 4 will give us 8, then roots. Then you multiply the radicals. 3 times 2 to give us what? 6. So we are able to get our 8 root 6. For example, so in a algebraic form, we can write as 2x times 4y, which is 8xy. Alright. Now let's see multiplying a set. If you are multiplying a set by itself, so if I have root a times root a, which is the same as, so if you multiply a set by itself, that's root a times root a, which will give you root a what? Squared, which will give you what? A. So let's say root 2 times root 2 automatically give us what? 2. Because root 2 times root 2, that will give us square root of 4. And the square root of 4 is 2, since 4 is a square number. Alright. Now if I have 3 root 2 times 4 root 2. Now watch carefully. We have 3 root 2 times 4 root 2. So we are going to do this. 3 times 4 to give us 12 root 4. And this is 12 times root 4 will give us 2. So this will give us 24. Alright. So if I'm giving something like this in a question and I'm simplifying, I can easily write 24 as my final answer. Now, we also have where you have binomial. If you are say binomial, means that you have, let's say, root a plus root b times, let's say, root b plus root a. Now, if you have something like this, how do you go about it? You just use expansion, because these are two multiplications. So use this one to multiply the whole bracket. So you have root a, b plus root a plus, then this one multiplying the whole bracket. We have root b, which will give us root b plus root a, and then we expand. So this is giving us root ab plus, so root a times root a will give us what? A plus root b times will give us b plus root ab. Remember in our previous video, in addition and subtraction, we said that we can add sets if the radicals are what? The same. And here you see the coefficients here is 1, the coefficient here is 1. So we can have a plus b plus 2 root ab. Alright. Now if I have 2 root 5 plus, let's say, 2 times root 2 plus 3. So all we have to do is take the first term here to multiply the whole bracket. So we have 2 root 5 times root 2 plus 3 plus 2 times root 2 plus 3. Then we will just expand. So we have a coefficient of 2 and a coefficient of 1. So we have 2 roots. Then we multiply the radicals, which will give us 10 plus. There is no radical here, so we just go 2 times, which is 6, then with 5 plus 2 root 2 plus 6. So you remember in the set, we said we can only add if the radicals are what? The same. But here the radicals are not the same. So this will be our final answer. Now another form of radicals is what we call the conjugate set. Conjugate set. The French student will be familiar with this word, conjugate, right? So, for example, if you are tired, my brain P. So to conjugate my brain, two brain, ele brain, one brain. Right? Now, it simply means in mathematics that to conjugate means that to negate something, right? So you are going to, so if I have a plus sign and I conjugate it, I'm going to get what? A minus sign. So if I have root A plus root B, the conjugate will be root A minus root what? B. If I have root 2 minus root 3, the conjugate here will be root 2 plus root 3. So to conjugate means that to negate the sign, whether plus or minus. Now, if you multiply a set by its conjugate, let's see what we'll get, right? Now, I have root 2 plus root 3, and I want to multiply it by its conjugate. The conjugate of this set is going to be root 2 minus root 3. So, root 2 plus root 3, root 2 minus root 3. Now, we've done how to expand sets. But I realize that here we have plus here, we have minus here, which is actual difference of two squares. And we'll be doing algebraic expressions, so we'll explain the difference of two squares. But for now, let's apply it here. So, we can expand, actually. We have root 2 times root 2 minus root 3 plus root 3 times root 2 minus root 3. So you see, root 2 times root 2 will give us 4. Let me write it. This will give us root 4 minus root 2 times root 3 will give us root 6 plus root 6. Then you see, positive times negative gives us negative. So this is going to give us square root of what? 9. Realize that we have 2. You see, negative, positive, the coefficient here is 1, this is 1, minus 1 plus 1 will cancel out, which is 0, minus 3. So, now if you multiply a set by its conjugate, it gives you an integer. Anytime you multiply a set by its conjugate, it gives you an integer. Let's try another example. Multiply this set by its conjugate. So I have 2 root 3 plus root 5. Now the conjugate set is going to be what? 2 root 3 minus root 5. Now, because this is a difference of 2 squared, we can easily go 2 root 3 all squared by this one, right? Root 2 times root 2 will be root 2 all what? Squared, which is root 4, minus root 5 all squared. And this is going to give us, now here we have, you see, this 2 is affecting the 2 and the root 3. So we can write it, this is 2 squared times root 3 squared minus, see, the square will go to the square, which is 5. And here this square goes to this, so we have 4 times 3 minus 5, which will give us 12 minus 5. And 12 minus 5 will give us 7. If you want to expand to using this approach, you get the same thing. So either ways, we are going to get the same answer. Alright, now let's move on to rationalization of sets. Or we are going to learn how to rationalize the denominator. If you want to write examples, you can pause the video and then write. Alright. Rationalizing the... Now, we said sets are irrational. So since they are irrational, when you have to rationalize their denominators, what do? it means that we don't need the square root. We just want to get rid of the radicals, all right, and get integers as our denominators. So to rationalize the set, for example, I want to rationalize the denominator of the following set. So I have root 2 over root 3, 2 root 3 over 5 root 2, and then root 7 over root 4, now 4 over root 3. Now, you write, if they ask, sometimes, yes, if you are doing advanced calculus, you can also be asked to rationalize the numerators. But here we are looking at rationalize the denominators. Now, because you want to rationalize the denominator, means I want to make it a real number, or I say a real number, an integer. You want to get rid of the square root. Then all you have to do is to multiply this one by itself, because if you multiply a set by itself, you get an integer, right? But then whatever you do to the denominator, you do the same to the numerator. So this is going to give us root 2 over root 3 times root 3 over root 3. So you see root 3 will cancel itself, so we are back to this. And then we multiply this time, this will give us root 6 over root 3 times root 3. If you multiply this root 9 is going to give us what? 3. Now be careful, don't go and say that 6 will go here. No, this is square root of 6. It's not 6, there are two different things. So your answer is root 6 over 3. Alright, or you can write as 1 over 3 square root of 6. Now let's take this one. We have 2 root 3 over 5 root 2. So we multiply it by the denominator, which is 5 root 2 over 5 root 2. Remember multiplication. So this will multiply this, which will give us 10 root 6 over this will multiply this, which is 25 to brackets. Square root of 2 times square root of 2 will give us square root of 4, and root 4 will give us 2. So this is going to give us 10 root 6 over 50. And this is an integer, this is an integer, so this one can go with this. So we have 1 over 5 root 6. Alright, so I hope you can try and then do the remaining ones. Now the last thing under rationalization is, what if you have a binomial? Rationalization that is binomial, the denominator is binomial. What do we do? So I have 1 over root 2 minus root 3. I want to rationalize this one. Now to rationalize this one, remember conjugate set. So it means that we have to multiply the denominator by its conjugate, and then we multiply it by the numerator and the denominator. So the conjugate here will be, this is going to 1 over root 2 minus root 3 times the conjugate, which is root 2 plus root 3 over root 2 plus root 3. So in this case, we are going to have root 2 plus root 3 all over. Remember, we said if you multiply a set by its conjugate, you get difference of 2 squares. And this is going to be root 2 all squared minus root 3 all squared. So we have root 2 plus root 3 all over 2 minus 3. So we have root 2 plus root 3 all over minus 1. Now, if you divide rational numbers or real numbers by a negative number, it affects both. So you are going to get negative root 2 minus root 3. Alright, let's take another example. Now I want to rationalize root 2 plus root 5 all over root 5 minus root 2. So, if you want to rationalize, of course, this is a binomial. So all we have to do is to find its conjugate, which is root 5 plus root 2. So we are going to do root 2 plus root 5 over root 5 minus root 2. Always focus on the denominator if you are doing rationalization, especially for the E-math students and then the commerce students. Alright, so we have root 5 plus root 2 all over root 5 plus root 2. So expansion. So you see, we are going to use this one to multiply these two. So root 2 times root 5 is going to give us root 10 plus root 2 times root 2 is root 4, which is 2, plus root 5 times root 5, that's root 25, which is square root of 25 is 5, plus root 5 times root 2 give us root 10. All over difference of 2 squared. So we have root 5 squared minus root 2 squared. We can add the integers. 2 plus 5 will give us 7 plus, remember this is a coefficient of 1, this is a coefficient of 1. So we have 1 plus 1 which will give us 2 root 10. All over, this is square root of 5 squared is 5 minus 2. So we are going to have 7 plus 2 root 10 all over 3. Now this can be written as 7 over 3 plus 2 over 3 root 10. Alright, so this is multiplication and the rationalization of sets, right? So you can check out for examples in your books. You can take the A plus or any of the textbooks that you have. Alright, see you in the next class. Bye bye.